real numbers. So what are real numbers? Real numbers are the combination of both rational and irrational numbers. Rational numbers are the one that can be expressed in the form of fraction as p by q, 2 by 3, and so on. But one condition, the value of q, that is the denominator, should not be equals to 0. It should not be equals to 0. Okay. Now irrational numbers are the one that are the opposite of rational numbers, which means they are root 2, root 3, so on, but these numbers cannot be in the form of fractions. So, and the next point is, these numbers means real numbers can be expressed on a number line. The number line, you can see the number line, the numbers that are expressed on the number line. So we have positive numbers as well as negative numbers. The numbers can be positive and negative. A number line consists of both positive and negative numbers. The numbers are positive and negative. Real numbers are rational and irrational, can be expressed on number line, and are positive and negative. Moving on to theorems. The first one is division algorithm. So a positive integers a and b satisfying the equation a is equals to bq plus r, where the value of r lies between 0 and the value of b, starts from 0 and end to any number that's lesser than b. For example, if the value of b equals to 4, then the value of r is 0, 1, 2 and 3, but not 4. Okay, so this algorithm is known as Euclid's algorithm, as Euclid's algorithm is completely based on division algorithm. Euclid's algorithm is mostly used to find the value of SCF of any two given numbers. Here is an example. Find the value of q and r. Okay. The value of a and b is already given. We have to satisfy the equation a is equals to bq plus r. So find q and r using Euclid's algorithm is the question. So Euclid's algorithm is satisfying the division algorithm. A is equals to bq plus r. Let's substitute the value. A is equals to 13, b is equals to 3. So how can we write into 4 plus 1, which is equals to 12 plus 1, 13 is equals to 13. So we get the value of q is equals to 4 and r equals to 1, right? As you can see, 4 as q and r as 1, right? Let's do a question where we need to find the value of HCF using Euclid's algorithm. As we have said, what is Euclid's algorithm? Satisfying the equation a equals to bq plus r. So this is a, this is b, this is q, and this is r. Let's take 300. How can we open 300 as 250? Let's take first 550. Okay, so we can open 550 as 300 into 1 plus 250, but we have to do until we get the value of r, which should be equals to 0, as r lies between 0 and the value of b, right? So we are going to do this until we get the value of r should be equals to 0. Let's open it again. We'll take this 300 as a now. Now open 300 as 250 into 1 plus 50. Let's take 250 again. 50 into 5 plus 0, 55 to 250. We got the value of r equals to 0. So now the value of SCF is 50, because when we elaborate 350, we get the same result as we elaborate 550. So the SCF of 300 and 550 equals to 50. On to the next algorithm, that's fundamental theorem of arithmetic. Every composite number that can be expressed as the product of primes. So what are the two numbers here? Composite number, prime number, right? So what's a composite number first? A composite number is a number that has prime factors more than 1 and itself. Like we have 1, it only has one prime factor as 1. 2, we only have one prime factor. 3, we only have one prime factor. So these are not composite numbers. Let's take 4. The prime factor of 4 is equals to 4 into 1, 1 into 4, 2 into 2. Yes, this is a composite number. 1 itself and more than that. Right? So every composite number that can be expressed as a product of primes uniquely is known as a composite number. So let's see an example. Let's take 720, right? It can be opened as 2 into 210. Then 210 can also open as 2 into 2 into 105. 105 can further open as 3 into 35, right? 2 into 2 into 3 into 35. Then 35 can also open as 2 into 2 into 3 into 5 into 7. We got the all prime numbers. This cannot be further open. So this method is known as fundamental theorem of arithmetic. Okay. So where this theorem is used, it is mostly used to find HCF and LCM. What is HCF? Highest common factor. So what's HCF? Highest common factor. How are you going to find the highest common factor? Let's take two values, 60 and 75. Right. Let's elaborate by using fundamental theorem of arithmetic. 60 can be elaborated as 2 into 30. Then 30 can go further, 2 into 2 as it is, 2 into 15. 15 can go further, 3 into 5. 2 into 2 into 3 into 5 as 15. Do for the 75. 75 can open up as 3 into 25. 3 into 5 into 5. Right? So, what are the common numbers here? We have 3 here, 3 here, we have 5 here, 5 here. Highest common factor means only the common things, that is 3 into 5, so which is equals to, the value is 3 5s are 15, 5 missing here, so HCF is 15. Let's go for the LCM now. Let's elaborate 60. We already got the factors, 2 into 2 into 3 into 5. So let's write it in the form of powers. What is LCM? Lowest common multiple. What does LCM says? Any exponential that has the power, okay, index power. So we should take only those exponentials in two numbers whose power exponential is the max. Suppose I'll just give you an example, you will understand better. As we see that we have two 2's, so it's 2 power 2. We have only one 3, 3 power 1. How many 5 you have? 1, so 5 power 1. In 75, we have 1 3, 3 power 1. We have two 5's, 5 power 2. So let's take those values which have the highest power, highest exponential values. 2, do we have 2 here? No, but we need to take each of those. 2 power 2, 2 power 2. 3 power 1, 3 power 1. We only have it 1, so let's take 3 power 1 as it is. 5 power 1, 5 power 2. Which is the greatest? Obviously 5 power 2. So we are going to take as 5 power 2. 4 into 3 into 25 equals to 300. The value of LCM is 300. This is how the LCM is going to be find. The best way to find LCM is using the method of writing L. I'll just show you. Let's take the value 60 and 75. Let's take 2 30s are 60, no 75 into table, 75 as it is. 2 15s are 30, 75 as it is again. Right, now we can take 5. 5 3s are 15, 5 1s are 5, 5 5s are 25, so it's 15. Now let's take 3, 3 1s are 3, 3 5s are 15. Let's take 5 again, 1 as it is, 5 1s are 5. Right, so what are the values? 2 into 2 into 5 into 3 into 5, which is equals to 300. So this is the best way to find LCM, but this one is the process of fundamental arithmetic. So the last thing we are going to see is now between HCF and LCM. So what does the relation says? First number into second number should equals to the value of HCF into LCM. The product of two numbers should be equal to the product of LCM and HCF. What were the numbers we took? 60 and 75 in the previous example. Let's take those numbers. 60 into 75 should be equals to LCM into HCF. Let's take any one. I am taking the value of HCF here. You can take the value of LCM as well, just to prove. So now it is 15 is in the place of multiplication. As it goes to the is equals to side, it goes to the division side. 60 into 75 is 15, which is equals to LCM. Let's cut it out. 5 3s are 15, 5 1s are 5, 5 5s are 25, 3 1s are 3, 3 2s are 6, 60. 20 into 15 equals to 300. The value of LCM is 300, which we got in the previous question. So this is the relation between LCM and HCF. Thank you.